Okay, my name is Michael Pankava. My title is Professor, and the course we're talking about is called Algebra for Calculus. It's Math 109. The main purpose of this course was to prepare students with the algebraic skills they will use in calculus. But it has the objective of a college course that we explore the process of developing a complicated thinking process in our students. So, for example, there's a subject that we do quite in depth, and that is factoring polynomials. And the students learn to apply a variety of tools to do the factorization. There's something called the rational zero theorem, Descartes' rule of signs, upper and lower bound theorems, and they learn to use a system to analyze something, so that they begin to understand that mathematics is not a science where you plug something into an equation and compute a number, but where you analyze something in depth for a long time. And what I've developed is a system where students get 5 different exposures to the material. The first, and it is a very important part of what they do, is the students read the sections that we're going to be working on before class. And then when they come into class, they have what are called laboratory exercises, which is a set of worksheets that they work on during the course of that day. And we meet for 2 hours with a 10-minute break in the middle. And the students don't find that this is burdensome because they're mostly actively engaged. So they work on the worksheets, and the worksheets cover the material that was in their reading. And then after they work for a certain amount of time on a page or a problem on a page, then we talk about it. 1 plus I, actually that's the only one they told you, right? But this is a polynomial with real coefficients. Does anyone notice I neglected to write that in the directions? What? But in any time I ask you this problem on a quiz or a test, I mean with real coefficients. So after they do the worksheet, that night they do homework problems on the material on the worksheet. The following day, some of that material is incorporated in the new worksheet, and at the end of the second day, they take a quiz, which is loosely based on their homework. So that's the 5 different exposures they get to the material, and it works pretty well for the students to become prepared. We teach students a variety of the tools that they need to begin to understand how to move from mathematics as solving an equation to mathematics as a process of discovery. Then we also teach them something that they come into the class believing is impossible to do. Students already know that logarithms are impossible. But we teach them that the logarithm is the inverse function of the exponential function. And if they can graph the one, they can graph the other. And they're shocked because they never imagined it was that easy. So the main trick that you're doing when you're teaching a math class is you're also exposing them to how people think when they solve problems using mathematics. First, one thing that people have some unusual expectation from mathematics is that it should be somehow useful when balancing your bank book or for some practical purpose, that this is the goal. Of course, these skills in balancing your checkbook and so on are very important, but don't represent what we're trying to teach in the math course. They make you a richer thinker. And so the real goal we have for our classes is to teach students to think more richly. And actually, it's important that they learn to think for themselves too.